So we looked at one numeric variable, how to plot them using distribution, kernel density plots, and so and so. We looked at one numeric, one categorical, right? Now we are looking at two numeric. So this is sort of similar to a scatter plot you would be doing in an Excel, right? And so here we are plotting two numeric variables, two numerical variables, right? Origination fee versus APR, okay? And it's coming. Okay, let me plot all of them just in case, okay? So here you see APR and origination fee, okay? And you have this regression. So this is a reg plot, okay? This is called a regression plot, okay? So anytime you have these two sort of numerical variable, it'll sort of draw a line around where it feels there is this trend, okay? So it's basically drawing a trend line, okay? And that's what it means by doing a regression plot. We're going to talk more about regression later, but just for now, just assume this is like a scatter plot, okay? And there are lots of other flavors of plotting you can sort of come across, and I think we glanced through that before, but feel free to explore, okay? And you can turn off this line if you want, which we have done here by saying fit reg equals false, okay? Let's look at this thing, okay? What does it tell you, okay? So this one doesn't, it does tell us something that as the origination fee goes up, the APR goes up, sort of, right? But not as revealing in terms of the information. It's not as information rich, okay? Let me say that, okay? Let me put it that way, okay? Let's do APR versus days late, right? Here you can sort of see that someone who's being charged a lower interest rate, okay? If I'm a bank, if I think you are a lower risk customer, I'm not going to charge you as high in interest rate because I want to keep you as a customer. I want to keep you happy, right? So I'm not going to charge you as high in interest rate because you're never late, right? Or you always pay on time. You don't run a lot of credit and so and so. As opposed to someone who is being charged 30% interest rate, you can see that it's more sketchy in terms of the payment history, right? So you can sort of glean some of this information, and there are these other customers who are all over the place. Of course, there are other reasons why they might be charged an interest rate of 25%. Like some of them should technically are never late, but they are still charged a high interest rate. There could be other factors, okay? And on behind the scenes, there could be algorithms which are basically predictive algorithms which are running, which sort of tells this bank as to what to charge to what customer, right? What type of customer, right? Let's look at two categorical and one numeric, right? So we are looking at two numeric variables. Now we are looking at two categorical, one numeric, right? So we can add a third layer, right? So we are adding a delinquency status as something, we assign it to something called a hue, right? And you have X and Y, and then we add a third layer, and we are looking at this. So it's a very messy plot, but you can still get a lot of information from this. For example, someone who has a very good credit history, right, is never going to be delinquent for sure, right? And it's typically only going to, is never going to be in grace, never going to be charged off, never going to be partially charged off. So it's going to have only 2 bars, right? Whereas someone on this side is going to have all sorts of stuff going on, right? So it tells us that, okay. We can also do a violin plot, which we already done here, right? And we can do by terms, I'm not sure what it tells you, but you can see you're basically splitting. So I'm just giving you a flavor of violin plot, right? You can split the plot between two sides, right? And you're splitting by term. On one side is 36 months distribution, on the other side 60 months distribution. So what it sort of tells you something, right? What it tells you is that when you're borrowing for 36 months, like shorter duration, you're typically charged a lower rate than when you're borrowing for a longer duration, right? In some cases, right? So in some cases, okay, when you get to the the credit or loan grade of C, D, and E, or at least C and D, that doesn't necessarily appear to be the case. So there could be other reasons, but it sort of gives you that that impression that that is what is going on, right? So shorter the duration of the loan, the lower the interest rate this bank is charging these customers. Okay. You can also do pair plots, right? So I've already done that here because it takes a little bit long to sort of generate these plots, right? But this is pretty. It has a lot of information. So you have diagonal and off diagonal elements, right? So diagonal is basically all the self plots, right? So basically, if you want to look at distributions, all the diagonal plots are the distributions. Okay. This doesn't. This has a lot of information being covered up, right? Same thing here, but this one actually has a very good separation. And let's see whether we can sort of understand. Okay, so APR. So this is the APR plot. It is distribution of APR by loan grade. Okay. And you can already see that AAA guys, the folks with a very good credit record, have a very tight band, and they are on the lower end of the APR scale, right? Whereas someone who is E, which is a high risk borrower, is far out of the APR scale, has a little bit of a distribution around that. Actually a pretty wide distribution of interest rate this bank is charging, and there could be other factors, as I said, why that bank is charging, right? You also have a lot of scatter plots, like, so it's telling you APR versus, okay, let's see, APR versus loan size. Okay, does it tell us anything? Loan size by loan grade. So APR versus loan size by loan grade. Okay, so loan grade E is typically higher up there. Loan grade, I'm sure you only have very small number of AAA, as we have seen, right? So you don't see a lot of data, but you can see all these AAA guys all the way at the bottom of the APR scale, and red are somewhere, A is somewhere in the middle. Okay, and so. Okay, so there is a lot to data visualization. This is just a very small sample of what you could do with data, and I think it's a very important aspect. I couldn't stress enough that anytime you're dealing with data, the first thing you would want to do is sort of try to understand different features, different flavors of what's going on within the data, right? So, and as I said, you're free to explore different avenues by finding out what you need to do with that data set, right? And you can always Google Stack Overflow and all those things, right? So you have all those resources available to you.